Again, your notes are on the back side of the notes from day 4. Find your day 4 notes. The notes are on the back side of the day 4. Today we're doing day 5. It's graphs of polynomial functions. So as then we're getting started, and the notes are on the back side of the notes we did last class. So the first thing, whether or not that your function is positive or negative, we get that from the leading coefficient. So we look at the leading coefficient. We look at the leading coefficient to figure out whether or not the function is positive or negative. To figure out if it is even or odd, this is from last class. What do we do? Where do we look? Yep. The number for the highest exponent. Okay, we look at that highest exponent. If it's a 1, 3, 5, 7, those are odds. 2, 4, 6, 8, those are evens. The number of real zeros, how do we figure that out? It's on the front page. It's going to be the second pocket. The first pocket's the homework. The next one is going to be the notes. No, look behind it. Behind that pocket. Behind that pocket. So keep going. That, yes, behind it. Yeah. That's notes. Yep. How do we figure out the number of real zeros? Highest exponent. Yep. How do we figure out the y-intercept, or what is the y-intercept? It's where you cross the y-axis, right? It's also when x equals 0. The domain is simply where your graph lives, left and right. And for all of these, for all polynomials, it is all real numbers. Okay, it's always all real numbers. For the range, though, you have to actually look. It's where does the graph live, up and down. So the range is up and down. The range can change, but the domain is always all real numbers. It's like an R, but it's got 2 lines, and then you connect it. It's not IR. It's just an R with 2 lines. So if I made it bigger, it's 2 lines, and then you start with this one, and then it's like that. You make that symbol. The local max and the local minimums, we're looking for the humps on there. So you're looking for local max is this part. It's like, I'm actually not going to do 2 of those. It looks like boobs. So hold on, let me erase this one. We'll just do that one. For the local minimum, it's like there. It's the bottom parts. So it's anytime that you get a hump and it's at the top, or a valley and it's at the bottom. So it's that point. And it's always going to be a y equals. So it's y equals wherever that y value is. The end behavior, to figure out the end behavior, this is always going to be the left arrow. This is going to be the right arrow. And we haven't talked about arrows, but that's what these are. This is the right arrow. And this is the left arrow. The right arrow, we figure out whether you're up or down based on whether you're positive or negative. And then the left arrow, we figure out based on whether you're even or odd. So the right arrow, you always do first. So that's kind of important. You have to do this one first and then this one second. So you have to figure out the right one first. So to figure out the right arrow, if you are positive, the right arrow is going up. Not that. I don't know what that is. If you're positive, your right arrow goes up. If you're negative, your right arrow goes down. Okay, so we're going to figure out the right arrow based on whether or not you're positive or negative, and this isn't going to make much sense till we actually start looking at graphs. For the left arrow, when you are even, both arrows point in the same direction. So when you're even, you're the same. When you're odd, you're opposite. So if you're the same, both point up or both point down. If you're opposite, then they're like that. Again, it's going to make more sense when we actually get to graphing. Name someone who might scold you for not seeing them often. Good job. All right, let's put all of that stuff to work. So for these questions, A, it is whether or not your graph is positive or negative. So whether or not you're positive or negative, you have to look at the right arrow. So looking at my graph, I have a left arrow and a right arrow. So this one, the right arrow, is pointing up. So it tells me that it's positive. Also, I can go ahead and do my limits. This one says, the way you read this, the limit as x approaches negative infinity, that means that as you read your graph pointing to negative infinity, the graph is doing what? Well, it's pointing down. So that's how you can answer it. It's pointing down. This one says the limit as your x approaches infinity. So as the x goes to big numbers, what's your graph doing? Well, it's pointing up. More technically correct. When you're pointing down, it's negative infinity. And when you're pointing up, it's positive infinity. But that's more like once you get to calculus. I am okay with you putting arrows for right now. So while we're at it, let's go ahead and put the limit for number 6. What do I put here?
Oh, down and down.
Down and down. So we talked about, this was the last thing that we talked about, based on how your arrows point, whether they point in the same direction or the opposite direction, tells you if you're even or odd. So that is B. I guess we can do also, this one is pointing down, so this one is negative. I should put over here A, this one is positive. This one is negative. So for this one, my arrows are pointing opposite directions. So is it even or odd? Odd. So one way you can remember it, odd, opposite. So for this one, my arrows are pointing in the same direction. Is it even or odd? Even. C says the number of real zeros. So we're going to go here and we're going to count how many times does your graph touch or cross the x-axis. So for this one, how many times? 1, 2, 3. Oh, okay. I should change this or add to it. This is the number of highest exponent. It's also the x-intercepts. That's what you're checking for when you have a graph. So this one, 1, 2, 3. What about this one? 2. It's just how many times that you touch or cross the x-axis. So this is the x-axis. And I touch or cross 1, 2, 3. For D, your y-intercept. For this one, where do I cross the y-axis? 0. So it is 0, 0. For this one, where do I cross the y-axis? 0, -3. E is my domain. It's the same every time. What is it? All real numbers. What's really, really, really nice about odd functions is that because they point in opposite directions, for an odd function, the range is also all real numbers. It goes up forever and it goes down forever. So the range for an odd function is also all real numbers. The range for this one, because it's even, I don't go up forever. The highest my graph goes is right here to 0. So my graph is below 0. And the way that you can say that is that y is less than or equal to 0. So for this one, do you understand that this graph points up forever and down forever? So the graph lives everywhere. For this one, I only point down, so I go down forever, but I don't go up forever. I only go up to here. So my graph is below 0 or less than or equal to 0. If the graph was pointing up, it would be y is greater than or equal to wherever the lowest point is. For G, G is my local maximum. And you can have more than one. So when I'm looking at my graph, the high points and the low points will be my maximum and minimum values. And they correspond with where they cross the y-axis. So for this one, I have a maximum at 2 and at 4. My minimum, it looks like I have a minimum here at 0. For this one, maximum values, those are the tops. So it looks like it's at 0. And then the minimum value is at -3. How are we doing so far?
So G and H are like the lowest and highest points.
Mhm. And it's where the, like, how high do you go and how low do you go? So it's the Y values.
Any problems? Injuries. That way. Illnesses?
You get more. Oh. Some old people get scrawny.
How about that? Graveyard? Funeral.
I don't know how to put that. People have to go,
Where did they get stuff? Yeah, I don't know why it's. I think it's like. That was the same thing. Library?
I think that was a good one.
Grocery store?
Not anymore. Like, you can order your groceries.
Think something people would eat every day, they're probably able sleeping alone every night. It's not the. Oh, I did say.
I think it's American. I agree. My kids like that. And I'm like, it's not cheese. Oh my gosh. I feel like I've answered this before and it was American, which I thought was crazy. Mm.
You did well?
No, because we were missing some. All right, this is the last thing that we're going to go over today. The first part, it says apply the leading term test. So the leading term is just looking at this first term. So the leading term test to determine in behavior. So in behavior, looking at that leading term. So there are some things that we're going to get from the factored form and some things that we'll get from the standard form. So from standard form, you can look at that leading term, and I can tell you that from the leading term, is it positive or negative? Positive. That means that the right arrow is going to go up. Okay. And then looking at it, hold on, I'll do it like this. I can tell that it is positive. So my right arrow will be up. And then is it even or odd?
Even.
3 is odd. So odd means that they go opposite directions. That means that the left one goes down. So those are my arrows. So if I have to put it in limit form, then I can easily put the right and the left arrow. Let's do the same one over here. So let's look at the leading term. So I haven't started looking at this form yet. My highest exponent is a 7, so that means this is my leading term. Most of the time, it's the first thing. So this one, I can see that it is negative and odd. So negative tells me that my right arrow faces down. How does my left arrow face?
Up.
Up. Part B, determine the number of zeros and state the multiplicity if any of them are repeating. Okay. So we're going to come back here and talk about repeated zeros because we're going to change this number. So you can either go through the x-axis or you can bounce at the x-axis. So here I bounce and I bounce. Do y'all see that there's a difference here in the x-intercepts and this one? You guys see that here I go through the x-axis and here it doesn't, it bounces off. So this is a repeated root. And we're going to repeat it as the simplest thing. So it could repeat any amount of even times. So it could repeat 2, 4, 6, 8. It's a multiplicity of an even number. So that means that it's called a repeated root or an even multiplicity. So we could say that that has a multiplicity of 2. So in other words, these are repeated. Here. So when we talk about these roots, and I should have been more clear about these being repeated. So we do have 3 roots, but this one repeats and this one repeats. And so instead of 3, we technically have 4, 5. So this would be a 5th degree polynomial. So I'm going to mark this out and I'm going to say 5 because those repeat. Technically, it could be 5 or any, like these could be 4, they could repeat 4 times. It has to be an even amount of times, but we're going to make it simple and say twice. Here, same thing. These are repeated. So that happens 2 times and that happens 2 times. So how many zeros do I really have?
4.
4. So that would really be a 4th degree polynomial, not a 2nd degree polynomial. All right, so here, when it says determine the amount of zeros and state them, determine the zeros and state the multiplicity. So all we're going to do is this is the opposite of what we did last class. So last class, I gave you the list of zeros and you wrote it as a polynomial. Now we're going to go the other direction. So for this one, if I have x minus 4, what does x equal? Positive 4. Remember, it's opposite. And if I have x plus 2, then what does x equal? What? Negative 2, but this one has a multiplicity of 2. See how it's got the square up there? So it's a multiplicity of 2. Let's do the same thing over here when we're looking at our factored form. What does it mean if you have x out in the front all by itself? X equals what? Think about your homework from last class. When you have an x out in front all by itself, x equals what? 0. And that's 0 with a multiplicity of 3. And then this one, x equals what? Negative 1, and this one's positive 1. This one is negative 5 with a multiplicity of 2. When we go to graph these, the only ones that affect your graphing are even multiplicities. What? Oh, it's a negative 5. Sorry, I put negative 2. I didn't mean to. -5. No wonder you gave me the stank eye. The only multiplicities that matter when you're graphing are even multiplicities. So here, this one matters. This one, we're going to bounce at -2. This one is an odd multiplicity, so it doesn't count, doesn't matter when we go to graph. This one is an even multiplicity. It's a multiplicity of 2. So this one does do something to my graph. I will bounce there. And what I mean by bounce is this, that I'm going to bounce at them instead of go through it. I'm going to bounce at those even multiplicities. C says, what is the y-intercept? For this one, what's my y-intercept? -16. Not that. 0, -16. And then what about for this one? 0. So now I'm ready to graph. So to graph this, I'm going to have to go plot these points. So I have a point at 4. And I have a point at -2. Those are my x-intercepts. But we need to remember that -2 is special because I'm going to bounce there. -2 is special because I'm going to bounce. I also need to know that I have a y-intercept at -16. So that's pretty far down on the graph. I don't have space, so I'm just going to have to put it way down there. So I know that that's probably like -12, but I'm just going to put it down there. When I go to graph, I will start with my arrows. I will start with the arrows. So the arrows, I know that on the right side, it's going to face up. So I'm going to always connect them to the rightmost 0 and the leftmost 0, or x-intercepts. So this one is going to leave and face up. And then this is my other x-intercept, and this one has to go down. So that's how I will always start using my arrows. So I have to, remember this one bounces, so I can't go up, because if I went up, like, how do I end my graph? You bounce and you go through down to the x-intercept. Then we cross the the y-intercept and connect it. It's not perfect, but that's kind of what the graph would look like. These are really hard to figure out on your own if you're like on your phone and not paying attention. So these would be really hard to do all on your own. The next quiz is going to be pretty easy. It's all this kind of stuff, but you're going to be lost if you don't pay attention. So we're done here. This one's graphed. For this one, to graph it, I need to go plot all my x-intercepts. So I have an x-intercept, which is also the y-intercept, at 0. I have -1, +1, and then I have -5, which is special. So mark it somehow different. It's special. You will bounce there. And then I can start looking at my arrows. So my right arrow is going to attach to the rightmost x-intercept, and it's going to face down. Down. My leftmost x-intercept is going to connect, and then I face up. From here, I remember that at my -5, it bounces. So it has to bounce off of it and go back up. And then all the rest of them, I have to just weave through. Like how high? No. So if you did your graph and you made it go all the way up here and then you came back down, don't matter. That's not bouncing. You cannot cross through it. So when it says bounce, you just hit the x-intercept and you have to bounce off. Most of the time, your zeros go through the x-axis. It's only special if you bounce. And it's only with an even multiplicity. And that is it for today.